All right. So we want to find all the zeros, real or complex, of this. So we want to start by just generating that list of possible answers. So I want to look at that last number. So P is 8. Again, I don't have to put -8. If you want to, it's fine. I want to think about all the factors of 8. And if you want to write them as pairs, like 1 times 8 and then 2 times 4, you certainly can. Or if you want to write them out, in an ordered list, you can. It doesn't matter. I generally put it in an ordered list, especially with a small number like 8, where it's easy to know if I've missed something or not. Then I want to think about what Q is, and actually it's really nice because Q is 1. So of course the only factors of 1 is 1 and 1 and 1 and 1 and 1 and 1. And so then we go, hey, what's up with P divided by Q? What it means is I take all of these numbers and I divide it by all those numbers. Well, all of those numbers divided by 1 are just all of those numbers again. So realistically, here is my list of P divided by Q's. Right? I'm just going to get all of those numbers back. Again, what the computer is going to want from you is to say that you're going to have 1 and then -1, and 2 and -2, and 4 and -4, and 8 and -8. Okay. So there's our possible rational solutions. Again, any zero that comes out of this problem that is rational would be in this list. So basically what that means right now, guys, we know like 5 is not an answer to this problem, or 7 is not an answer to this problem, or 23 is not an answer to this problem, or 1/3 is not an answer to this problem, or 2/5. Like none of the numbers that I'm saying here that don't show up on this can be answers to this problem. Now we could have square roots as answers because those are irrational. This is a list of rational answers. Or we could have imaginary answers because those are not rational. But we know that any rational numbers have to be in this list. Okay. So now we need to go to the graph. Right? And you guys do need to be doing this. So even though I'm doing it, you guys need to be doing it too, because it's basically gonna be like muscle memory. Okay, first thing I do is this, and then the next thing I do is go to the graph. But if you're not practicing going to the graph, you're not going to remember to do that later. Okay. All right, Colby. Right. So even though I'm doing it, you guys need to be doing this too. Get your calculator going, get your app on your phone going, get your pulling up Desmos, graphing this. Okay? So you know what you're supposed to be looking at, and also just practicing using those platforms. Not that one. It was that one. So most of the time when you like open a graphing calculator, the window is set to like a 10 by 10 window. Okay, so I tried to kind of mimic that here. And if you really ever need to, if you're in Desmos, if you hit that little wrench up in the top corner, where I'm looking here is where it says x-axis, kind of towards the bottom middle. Notice how the first number says -10 point something something. If I want to make it like perfect, I would just type -10 in there, make this +10. Same thing on the y one, I would take -10 to +10. Oops. All right, so that would be my little perfect 10 by 10 window. Okay, so that's normally what we would see. All right, what are we after here, right? We're after zeros. And zeros are also called x-intercepts. And so as I tap on this, because the app's all friendly, it's a little clustered, especially this, like if you see those little bunch of gray dots over there on the right side, it's a little tight. So I'm going to zoom in. Okay. So of course, what's nice about apps is you can just do the little pinch thing and it zooms in for you. And now I can see the x-intercepts a little clearer. If you have your graphing calculator, again, what you need to do is go to the window and bring your window in, especially your x values. Like go from like -3 to +3. You kind of see things on this particular graph. Things are pretty close to 0. And then also what's nice about the apps is you can just tap on the x-intercept and it tells you what it is, which is like having to do a couple more steps on a calculator. Of course, if you guys are going to take the ACT or whatever, if that's still a thing, then you'll need to do. You can't use an app on ACT. So learning how to do that is also has its value. All right, so what do we see? Right, what's on our list? Right, and on the graph. Right, of course, there's 2. Right, these other things are all decimals. Right, so it's not what we want. Those are not rational numbers. Obviously, we didn't see 8. We didn't see -8. We didn't see 4 or -4. Right. And we didn't see -2, we didn't see -1, we saw 2. And that was the only one that showed up there. Again, the reason I'm writing this is so that you guys write it so that later on you remember why we're doing what we're doing, okay? I'm not asking you to write this come test time, right? But it's just explaining your thinking to yourself later. Okay, so that 2 is going to be on the outside of our box. And then we need to get our coefficients onto our box, right? So I got a 1, I got a -6, got a 10, got a -8. Okay, so we're going to divide out that answer that we know, right? We're pretty darn sure that 2 is an answer, so let's get rid of it. Okay. You guys all good here? What are you talking about, Ruth? There's a gap? What are you talking about? What's this gap business you talking about?
There's not an X, so we need to put a 0 in place for it.
Ah! Good job, Ruth. Good job, Victoria. You guys are the only ones that have caught that today. Everybody else has let me do it wrong. And we had to go back and fix it. What do I always say? Check for your gaps every single time. Okay. So bring that 1 down, times 2. Add, we get -4, times 2 is -8. Add, we get 2, times 2 is 4. Add, we get 4, times 2 is 8, which we love because it proves that it was a 0. Right, there's your first little built-in check, right? We said it's a 0. We thought it was a 0. Yes, it's a 0. There's one of our answers. We're supposed to have 4 answers. There's one of them, right? So let's write that resulting polynomial over here. So that's our remainder. There's our constant, our x squared, our x cubed. So x cubed minus 4x squared plus 2x plus 4 equals 0. So this is a little bit different than what we saw yesterday because, yesterday we started off with a cubic, and then when we took out an answer, we ended with a quadratic. And I'm like, okay, how do we solve quadratics? And we talked about all of those different ways we know about solving quadratics. Well, now we have a quartic. Take out an answer, we end up with a cubic, right? That makes sense, going down from a 4 to a 3. And so now we need to say, well, how do we solve this cubic equation? So that's kind of our internal dialogue here. So how do we solve that? So try GCF, right? Is there something in common in all those? Maddie, do you see anything in common?
No, but I was thinking of when you split the problem in half and then go through.
Victoria, what are you thinking about? What's that called?
That grouping?
Yeah, grouping, right? So what made you think about that, Maddie or Victoria? Why were you thinking about grouping? What's saying, let's do grouping?
I just noticed there was 4 terms.
4 terms, right? So 4 terms, go grouping, right? So we try it, right? So we say, well, there's x squared. That leaves me with x minus 4. And then those two have a 2 in them, so that leaves me with x plus 2. All right. Alicia's saying, this isn't working. Did we do something wrong? Did I factor it wrong?
I don't think we did anything wrong.
Okay, so we didn't do anything wrong, then what does that mean? Still not working. What's that mean?
It's not factorable.
It's not factorable, yeah, by grouping, right? So back to the drawing board, right? So what did we miss, right? We missed something. We missed something. What did we miss?
Was the y-intercept a solid number?
Yeah, you can see it over there on the side. Granted, it's -8. All right, so it's crossing down there at -8. Yep. Ooh, Maddie. You have Maddie saying there in the chat? So what's that mean, Maddie? Bouncing. What does that mean?
That we know 2 of the x-intercepts because
Yeah, 2 of the x-intercepts. Yeah, awesome.
Why?
So 2 of the x-intercepts are 2. Right? And again, that's just a coincidence. Okay. It's just a coincidence that 2 of the x-intercepts are 2. Okay? Very easily, the 2 of the x-intercepts could be 3 or 1 or -7. Okay? It's just happen to be 2. Okay. So yeah, it's bouncing at 2. That means 2 is 2 of the x-intercepts. And so what we can do with that, and some of you guys might remember doing this last year, is that, so I'm going to go ahead and, talk through this here, right? We see a bounce at x equals 2. So what was that word we were using when we were talking about the bounces and twists and stuff like that? What was that word we were using? Hyper, remember? Caleb, remember? It was on that last test you guys took last semester, so long ago. Gold, Tiger, Wesley. What was that word we kept using over and over again? We're talking about bouncing and twisting and passing through. Right on, Katie. Multiplicity. Again, this is a coincidence that 2 has a multiplicity of 2. Okay. What that means is that I can take it out again. Okay. So we're gonna do, and some of you guys might just remember this visually, that we can do layers of synthetic, is what I like to call it. So because 2 shows up twice, we can take 2 2's out. What we do though is we cross out that last column. We don't need that 0 anymore. Okay. You want to do it like this. You want to stack it like this because we want those numbers again, or else you have to create a new stack. You do not want to use your original numbers. We need the numbers after 1 2 has been taken out, and then we're going to go take another 2 out. Okay. So I get a 1, and then 2 times 1, of course, is 2, plus -2. That's going to be -4 plus -2. Should give me -4 plus, and these are 0 again. Okay. So I just want to be real clear that this would only work if that number had showed up multiple times within the problem. Okay. If I go and I divide a 2 out, and then and there's only 1 2 in the problem, and I go and I divide it out, and I try to divide it out again with my new numbers, it will not work. Okay. This only works because there's a bounce at that point, and that means there's multiple values, multiple of that value at that in this function. So, okay. So seeing that bounce tells us that we can do this. If you don't see a bounce, then you better not be doing this. Okay. Does that make sense, guys? So put the x's back in, so we get x squared. I'm going to push this over because every time I've done this in other classes, I get run out of room. So I'm bringing this over here. X squared minus 2x minus 2 equals 0. Right? So there's our resulting polynomial. We set equal to 0, just like we tried to do earlier, and we couldn't factor that by grouping, so we had to take a different tack. Okay, and so now we're here, right? How do we solve this? So we just, we were talking about it yesterday. We got, 3 main things you guys should be trying to do when you're solving a quadratic, and the first 2 are more precise. They only work sometimes. AC method, but if it works, it's fast. Solving by square roots, but if it works, it's fast. Then you got your sledgehammer, which is the the quadratic formula out there, which is messy, but it always works. Okay? So looking at this, I shouldn't be trying to do square roots because it has multiple types of x's. So I'll be saying, okay, AC method, right? And so you go, well, my AC, A times C is -2, and I need -2 to add to -2. Any factors of -2 that add to be -2? Factors of -2 that add to be 2 are -2. Nope. All right, yep. So can't do AC method, so then we go after the quadratic formula. Okay. Again, save yourself time, because if the AC method works, you'll be so much better off. And I think all the problems that we've seen so far have had to do the quadratic formula. It's not like that in the homework. So just FYI, keep after the AC method, because it will work, and it'll be so much faster. So make sure you're writing x equals when you're doing the quadratic. Matt, what's my b value? What's my b value, Matt?
Would it be -2x?
No, it's not. The value doesn't have the x, it's just -2. Yeah.
No, just saying. Sorry.
Right spot. Yep. Just don't say the x. Wesley, what's our a value? Okay, 1. We got our 1 there. Riley, what's our c value? Okay. All right. So you need to run this through. Then you really shouldn't be reaching for a calculator. You should be able to do all this. So we get +2 plus or minus over 2. 2 squared is 4. Remember right here. So you need to see this as a negative or a minus. You can't see it as both. You get to pick right now, decide what it's going to be. Okay? I say that's a negative. So I have a negative, that's going to be positive. So when I get +8, I go and I write +8. I don't write minus +8. So you decide, and it's that for the foreseeable future. Okay, you gotta call it something and work with that. And then still running out of room. Move it over. What's wrong with me? That's 2 plus or minus the square root of 12 over 2. It would be very inappropriate to try to reduce this right now, try to do that division right now, right? We need to simplify the numerator completely before we can divide. And so that square root of 12 there needs to be dealt with. Now, I don't care how you guys deal with it, whether you're using the SOC method or whether you're using the product property method. You need to show me what's happening to that 12, though. For it to just all of a sudden change into something else, I'm not so happy about that, seeing that from you guys. So where is this 12 going? How is it changing? I'm expecting to see that. So, what I always show you guys is the SOC method. So breaking that 12 down, saying, okay, that's got a pair of 2s, and it's got a, I don't want that color. It's got a 3 in it, okay? So that equals 2 plus or minus 2's come out. 3 stays inside because he's lonely. All over 2. And now that I'm completely done simplifying the numerator, now I can look for dividing. And so these all have a 2 in them. I don't care about that guy since he's under a radical. Here are all my 2's. So x would equal 1 plus or minus 1 radical 3 over 1. But we don't write stuff like that. It'll just be 1 plus or minus radical 3. So as far as what the computer is going to want from you, you're going to say like x equals, what was our first number? 2, that's right. We took out a 2, then we took out another 2, and then we took out a 1 plus, or then the other answer was 1 plus square root of 3, and 1 minus square root of 3. You do need to write both 2's, okay? That's the only way the calculator or the computer knows that you know there's 2 2's. All right? Again, if it was me creating this, I would know that you had done 2 2's earlier, and you could just write 2 1's. And you could also write plus minus. Okay? But the computer needs to know that you know there's 2 2's. So you got to make sure you type both of them. All right? These are big problems, guys. You're having to do a lot of thinking, a lot of interpreting, saying, okay, here's what I see. That's what this means. This. So I'm seeing this other thing this time. It means this. Here's what the problem looks like. I should try solving it like this. Like, there's a lot of thinking going on. It's not just do. And stop at this point and say and evaluate. What do I do next? Like, what's this telling me? Oh, this isn't going well. I better turn back around and go do something else, right? When we hit that point right here, this is not working. How do I go back? What's the next thing I try then? That's not working. There's a lot of thinking going on. A lot of skills too, right? Factoring skills, and simplifying radical skills, and synthetic division skills. Like, incorporating a lot of skills here and a lot of thinking. These are big problems. And these are great algebra problems. Like, for me looking at you guys and saying, do they know what's going on? Do they know a bunch of stuff about algebra? This is a great problem for me to ask you. Anything, any clarification on before we hit this last one? Okay. So 2 nights ago when I was, getting myself ready to teach you guys this yesterday, and I went through the notes and was trying to make sure I knew what was going on, kind of get my thinking going how I was going to teach you guys. When I read that, I did not see this. I read the problem. I did not see that little thing over there. For whatever reason, I just, even though it says given that, I didn't bother trying to figure out given what, and that was going on with me. It was probably late. So and as I tried to solve it, just like the way we just did, it wasn't working. Like things weren't coming out pretty. So I was like, okay, was there a typo or something? So I tried to figure out what they meant, and and I couldn't, figure out, maybe exactly what had gone wrong. Whoever typed this up until, and I was like, well, if I change the problem just a little bit, it starts to work. And so that's what I ended up doing. I ended up changing the problem. Need those both to be 13s. And I'm going to go ahead and ignore this, given that I is 0 business. Normally I wouldn't ignore my mistake of that, but there are no problems in your homework where you're given like a 0 that's I. So me showing you how to do this really isn't going to help you guys progress. I'll just show you another problem, kind of like what we've been doing, because that's what the assessment's going to be like. So, okay, so scratch out that I is given business and then change those to 13s. And I'd actually like to ask you guys to go ahead and do this on your own. A good check-in point for you guys would be here. Get through your P's and Q's, get out, use your graph to find the first thing you want to divide out, and do that and get to this point where you're here, and where you've written your polynomial. So if you want to check in with me right there and see how you're feeling about things, then that's a good place to do it. Okay, get to this part, see how things are feeling, and then if you're ready to progress on your own or if you need to wait for me. Okay, so find your P's and Q's, graph it, get rid of something, write that resulting polynomial, and see how things are feeling for you and let me know. Okay, I'll be sitting here waiting for you. We got about 15 minutes still, so maybe in about 5 minutes, we'll check in and see how you guys are doing. But let me know if you got any questions. So getting through the P's and Q's and going to the graph, you should notice very easily that 2 is one of the zeros. Yeah, and then taking that 2 out, you should have 1, -11, 1, -11, 0. So we know that 2 did work, and then so we can turn that into that polynomial there. Is that like you were trying to say, Grant? Okay, so then you said you could factor that by grouping, and Ray, you said that same thing, that we can do this factor by grouping. Or try it, right, and see what happens this time. And it turns out this time this works. So x squared times x, and then minus 11. And these two have a 1 in common, so I take that out and I get x minus 11 again. And then, so we say, okay, that's x minus 11 and x squared plus 1 equals 0, right? And so we're here, and we look at this and we say, okay, well, this is done factoring because there's nothing in common and there's no higher order powers here, right? And then we look over here and there's like, okay, there's nothing in common, but there's still a higher order power, so we should say, the next question is there more factoring to do? Right, we get to that point and say, can we do more? Can this be factored more? So can we do the square thing, right? So Elijah's asking, can we do this? Well, how do we know if that's right, Elijah, right? How do we know if our factors are right? Well, we could always multiply them back together to see if we got what we started with. So Elijah, if you take x plus 1 times x minus 1, are you going to get x squared plus 1? No, right? So then that, we can't do that, right? What was this called? What type of factoring is this when we end up with these? What was that type of factoring called?
Difference of squares.
Difference of squares, right? And that first word is difference, and difference means subtract, right? This is not subtraction, right? So that right there is saying, nope, can't do that, right? And then we have to know that, okay, that means we can't do x plus 1 times x plus 1 either. Because again, if you take x plus 1 times x plus 1, you do not get that. You get something different, right? And the answer here is that there is no more factoring. We can't do AC method. We can't do different squares. Okay, there's nothing that will factor this. It's not factorable. So if we can't factor it anymore, just like we couldn't factor this anymore, that means we move on to solving it. Okay, can we solve this as an equation? So if we take x squared plus 1 and set it equal to 0, can we solve that? Yes, no? Yeah, right. So we kick that 1 over, and then we square root both sides. This should be screaming at you. What's that telling you right there?
Imaginary.
Imaginary, okay. And then there should be something else screaming at you saying, every time I square root, every time I square root, every time I square root. Plus minus, right? Okay, so it's a couple things that should be screaming at you here about this. Are they things you're going to remember? Are you going to remember that there's supposed to be 2 answers here, right? It says that right there. Hey, there should be 2 answers. Hey, there should be 2 answers. Are you going to remember that there's a positive and a negative answer? Do you remember how to square root negatives? Okay, so these can be little things that might have slipped your mind, right? So you need to get that back in there. Okay? So there's 2 answers. There's a third answer, and then we had that 2 a while ago. Right? So there's 1, 2, 3, 4 answers like we thought we should have. Okay? So x equals 2, 11, I, and negative I. That's how you would type that in. Okay? Alicia, you said something different earlier about how you were solving. Did you end up doing that or no? No? Okay. So what might be a little bit tricky about this one, I don't know, did any of you guys see, or Grant, you saw it on the graph, like that there was another 0, right?
Yes.
So when you graphed it, you guys should have seen 2 x-intercepts, but the problem is that one of them was 11. So if your little window is a 10 by 10 window, 11's on the outside of the window, right? You wouldn't see it. So, it is a good idea to zoom in and out a little bit when you're doing these to make sure that you're actually seeing everything you should see. Now, obviously, us missing the 11 didn't end up mattering, but we could have, at this point, done that. We could have said, well, I know 11 is also an answer, and I could have run an 11 through there. And then we end up with, there's my remainder constant x squared, and so we end up with x squared plus 1 equals 0, right? And so obviously we're in the same place as we were right there. We know that 11 is an answer, we know that 2 is an answer, and we still need to solve that. So it gets us to the same place, just in a little different path. Okay? Do you like one of those methods more than the other? But you got to watch out, right? Are you going to see a bounce, right? You can recognize what a bounce is, and say, okay, I can take that 2 out twice, or that number out twice. Did you see all the x-intercepts that you're supposed to? Okay. Ruth, you had a question earlier. Would you like to voice that question so that we can all talk about it, even though you might know or know the answer to it now?
I meant to say 2 zeros, but
No, you're fine. You said it was just fine. And what was the issue you brought up earlier?
when I graphed it, it showed 2 x values, and I didn't know which one to use, or because my equation was right, but.
Oh, okay. Maybe I thought you were asking a different question. I thought you were asking why weren't you seeing 4?
Oh no.
That's what I wanted you. That's what I wanted you to be asking. Right, why aren't we seeing 4 x-intercepts? Right, there's supposed to be 4. There's supposed to be 4 zeros, right? Zeros are very similar to x-intercepts. So why aren't we seeing 4 x-intercepts? Alicia's sassing me in the private chat. She's bullying me. Right? We see the 2, we see the 11, but we don't see the magic rolls, right? Okay. That's how you try to make sense of this, guys, right? Like, I'm supposed to be seeing 4 x-intercepts. Why am I only seeing 2? Or, oh, maybe 2 of them are imaginary. I can't see them. Okay. If you look back at the last graph, we were supposed to see 4 x-intercepts, but we only saw 3 because one of them was a double. Okay. So there's a reason that the graphs do that stuff. They don't match maybe what we think they're going to do. Well, there's a reason for that. Okay. All right. You guys feeling okay about all that stuff? Big problems, man. There's a lot going on. Don't be feeling bad about yourself. There's something not catching. Okay, there's a lot going on with these. So, right. Give it a shot over the weekend if you can. Come Monday, questions. All right. Appreciate all you guys are participating.
Thank you.
See you, Ruth.
We're just going over the same time, yes?
Similar. Yes. We're going to build on that.